Welcome everyone. We'll get started. We'll let others join as they come in. Thanks for joining us for the orientation for the RoboRacer Sim Racing League that's taking place at ICRA 2025. First of all, we'd like to give a huge shout out to the organizers. While Chinmay and I would be doing most of the talking today, it's because of these people that you see on the slide that the competition has been possible. There is a lot of things that go behind organizing such a competition, so we just want to acknowledge everyone's efforts. Another small thing about getting in touch. So most of the announcements or prominent items will be posted on the competition website. And the first QR code that's shown here takes you there. Other than that, any general communication or question or any other kinds of even casual engagements will be done via the Slack workspace. And the second QR code basically takes you there. This is also a place where we also will be announcing any updates or interim uh, changes or timeline updates to the competition as well. The third QR code is for the GitHub repository, and that's primarily for any technical questions or issues or pull requests that you may have related to the competition framework in general. And finally, we have given our emails. The reason we have emails listed as the last option is primarily because of the spam filters of different organizations. So us communicating to you or you communicating with us may or may not go through as smoothly as planned. And especially for time critical things that may create a issue. So that's why, yes, you can contact us via email, especially if things cannot be posted publicly. But other than that, we try to ask you to stick with the Slack workspace as the primary mode of communication. So what we will be discussing today is itemized in the following slide. First of all, we'll be talking about the competition in general, how it's going to be conducted and things as such. We'll then delve into the rules and regulations for the Sim Racing League, followed by the different technical aspects that you should know about while you are developing your solutions and also how we would be evaluating them. And then we would be giving you a few demonstrations of how to work with the competition framework for Sim Racing League. And finally, we'll open floor to any questions if you have any. So first, let me delve into the competition overview. So this is going to be the 24th RoboRacer competition that's going to take place at ICRA 2025. We have two versions. First is the Physical Racing League, which is going to be an in-person competition during ICRA, and that's during the conference dates, which will be using a physical RoboRacer race car within a physical racetrack at the conference site. And the qualification for this would be a time trial based race followed by a head to head autonomous race for the awards. And the first QR code will take you to the physical racing website where you can uh, find more about this. But what we'll be talking about today mostly is about the Sim Racing League, which is a virtual competition that will be held ahead of ICRA, uh, approximately a week ahead of ICRA to be specific. And we will be using a virtual environment or a simulation based environment with RoboRacer digital twins within a virtual racetrack to conduct the competition. And the primary mode of this competition is going to be a time attack format of racing where you would be competing against the clock. And the website for sim racing is separate from that of the physical racing, and that can be accessed via the second QR code. So let me delve a little bit now into the details of the Sim Racing League. So all of you here have already registered for the Sim Racing League. So the second task today is for the orientation, where we will be explaining the rules and regulations as well as demonstration of how the simulation framework is to be used and what we would be doing from our side while we evaluate your solutions as well. The next thing is going to be the qualification round, where you would basically give us working solutions of safe autonomous driving algorithms, where the idea is that you should not crash a lot. And the details for this we will be covering, but basically you will have to complete 10 laps around the given same practice track that has already been released and show us that your algorithms are capable of doing that without colliding a lot. Following that, before the final race, we will be releasing a different track, and that's what's called the competition track, where we will be changing the size, shape, and the features of the track significantly. And the idea is that you should have your algorithms robust enough that can generalize to any other track as well. You will be given a finite amount of time to retune your algorithms for performance, but the idea is that they should still be robust enough to generalize to a new track. And this track that we will be releasing for the final competition may be also the same track that you encounter in your physical racing league. It may or may not be, but it can be. So it would be a good idea to tune your algorithms on that. And in the final race, we will be again collecting your containerized solutions and connecting them with the final racetrack version of the simulator and recording all the metrics from all the teams. And based on those metrics, the time, the collisions, and all of that, we will be then declaring the results for all the teams publicly on the website. So here is a timeline that has been tentatively followed and will be. So today we are at the online orientation, and the next big step upon us is on the 3rd of May, where you will have to submit your qualification submissions by the end of 2nd of May so that we can run them on the 3rd and declare the results on the 5th. And similarly, the final race is scheduled to be around May 10th and 11th. And the competition for track for that will be released a few days ahead. So you would have a couple of days to fine tune your algorithms, but not necessarily dependent on changing your algorithm completely to now adapt to the different track. And finally, we have tentatively proposed May 12th as the date for declaring the results. We may go a day here and there, depending on how many submissions are there, how many of you do a good job of cleanly submitting, and how many challenges we encounter. But hopefully, we should be done well ahead of the conference. So here are a few resources in case you haven't looked at. This is just a screenshot from the website. So if you go to the competition website for Sim Racing League, this is exactly what you would encounter. So first of all, you have different documentation. So first is the rules. We will be going through the key or prominent rules in this orientation, but the detailed rule book is available online via this link. We also have a detailed technical guide. Again, in today's orientation, we will be touching on most important pieces, but for other details, you are highly encouraged to refer the technical guide. The second types of resources are the Docker containers. So these are both the simulator and the dev kit containers, where we have released different tags for different types of the containers. So the Explorer tag is basically the RoboRacer car in a completely flat ground environment. And it's typically meant for you to run any experiments for system identification or trying to tune your algorithms, trying to identify the limits of the vehicle, etc. The second tag is that of practice, which is the Porto racetrack digital twin. And that is the same racetrack that is available ahead of time for you guys to develop your algorithms on. And that's the same racetrack or the same simulator that we will be using for the qualification round. And finally, the third tag is that of compete, where we will be releasing the final racetrack for the competition ahead of the final round. And that's when the links for the compete tag will be available. We also have provided local resources in case people have issues getting started with Docker containers directly. So this is basically both for simulator, you have standalone executables for Linux, Windows, as well as Mac OS. Again, for the explore, practice, and compete tags, as well as the dev kit, which is a ROS2 based framework. And finally, we have also provided other quick links in the website for you to take a look at the schedule or say go to different types of resources for orientation or even just quick links for the results or submission forms. And a link to join the Slack channel as well. So let us know if you have any issues or problems accessing these. And another thing that I want to highlight here is in terms of downloading the resources. So as I mentioned, we have containers and local resources linked here. We 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 don't want to stress it much, but it has happened in the past that people have downloaded Autodrive Simulator from other places, including past competitions. So we just want to make it clear that please download all the resources related to ICRA 25 competition from the ICRA 25 website for the competition. And that is these links that you see here, because other simulators, other dev kit versions may or may not be compatible. They may not be as performant as these are. They basically are not meant for the competition. So you may face issues later on. So in order to avoid that, we ask that you download everything from the competition website itself. So now let's delve into the rules and regulations a little bit. We have tried to categorize the rules or guidelines in terms of three key aspects. One is the general competition guidelines, then the guidelines that are specific for Sim Racing League, and finally some guidelines for submission. So let's go through them one by one. So as you would know, because you have already registered, this competition is open for everyone around the world. And the registration for Sim Racing League is free of cost. Please don't misunderstand this with the registration fees for the conference itself, that's ICRA, or the physical racing league. Those are separate. Like they incur charges for their organization, and that's why they may have their own registration costs. So don't confuse them with these. The second thing is the competition structure, where, as I explained, we will be providing everyone, that is each one of you, a standardized simulation setup in the form of containers or local versions. And your task would be to develop the perception planning and control algorithms that interface with the simulation in real time. And you would be providing us back with a containerized version of your algorithms. Again, the base containers for developing the algorithms have also been provided to you. And in terms of the competition timeline, we will first have the qualification race, which is going to be in the first week of May. And then finally, the final race would be a time attack race, which would be just a few days ahead of the conference. So coming to competition specific guidelines, the competition format that we are following is a time attack racing format, where you would be racing against the clock independently on the racetrack, but the racetrack would be the same and the vehicle would be the same across all the different teams. So it's just a battle of algorithms that we are going to see. And you would have heard me say about 10 laps till now, probably a few times. But technically, we would be offering you 12 laps worth of competing, where you would be starting with a warm up lap, followed by 10 race laps, and ending with a cool down lap. And the reason for this is simple. The timers that we are using for you to get started is basically because you would have most of the teams face issues when they are starting. So that's why we are giving you a warm up lap where you kind of go around the track. This might be just for localization or anything else. But the main race would be, or the metrics would be locked for the 10 race laps. And then an ending lap is just so that you ensure that you have completed the 10 race laps. And if you want to do anything after that, like a victory lap or something, you can basically have that as the cooldown lap. So the evaluation criteria is simple. The first and foremost objective of any race is trying to complete the circuit in minimum time. So that's going to be the norm. The total race time for 10 laps, the 10 race laps, is going to be considered as the main criteria. But we will be also considering the collisions to adjust this total race time, and I'll get into that, as well as considering the best lap times or other metrics in case of a tie. So coming to the collision, each collision will incur a penalty of 10 seconds. That is, for example, first time you collide, 10 seconds will be added to your time, the second time, 20 seconds, and so on. And the maximum number of collisions permissible for any race, that can be for the qualification as well as the final competition round, is 10. So if you collide more than 10 times, your team will be disqualified from the race. And all of these video recordings as well as data will be made available to you transparently so that you don't have any issues analyzing your algorithms, where they are failing and why they are failing. But those are the norms set for the competition. And finally, as I said, the data or any metrics for the warm up or cool down lap will not be considered. That includes both the time as well as the collisions for those laps. Only the time for and the collisions for the 10 race laps in the middle will be considered. So let me now take a moment to talk about the submission process. As I said, you will have to submit your solutions as containers. And we expect that these containerized solutions be self-sustainable in terms of deployment. And what we mean by that is explained in the further slide. But the idea is basically once we connect your container with the simulator, everything within that container should be executed automatically. We have provided a few example entry point scripts for you to take a look at on how you could basically execute your setup so that it interfaces with the simulator as soon as the container is spun. Most of these submissions will be handled via Docker Hub or Docker in general, the containerization platform. So you would be basically, after developing your solutions, you could develop them locally and then containerize them, or you could develop them within the container itself. But ultimately, you will be pushing that container to the container registry for Docker Hub, and you would be sharing a link with us securely via a submission form. Once you have done so, we know that this is a competition and we respect your privacy. So here are a few guidelines on how you could privately develop your solutions while the competition is still ongoing. So for developing the code base, you can use a private repository within GitHub, and GitHub does allow you multiple private repositories, so that shouldn't be a problem. This can be very useful for version control, or in case you have any collaborators, you could add them and collaboratively develop your algorithms. The second is for the container hosting. Again, Docker Hub does provide you with one private repository per account for free, and you could leverage that. In case you already have a private repository under your account, you could simply create a new account, and then you could have one more free repository from that account for the competition. And that way you can host your images onto Docker Hub for free and in private repositories. For the two phases, that is the qualification and competition round, you could use the tagging system that I just talked about within the same repository, so that the containers are separated by different version tags within the same repository, rather than having a different repository altogether for the final race, so that you don't need to create an account or pay for the additional private repository for Docker Hub. That being said, after the competition, we highly encourage all the teams to publish their source code, Docker images, any other data from the race, or even if you have any publications out of the competition, so that everyone from the community can benefit from your developments and your contributions. So here we have a video of how we execute the submissions, and this is for you to get an idea of how we expect the submissions to be made as well. So here, for example, we have downloaded a submission container and we are running it. The container name is of course hidden for privacy reasons. First, we execute the container, and this container execution step is expected to spin up all the related setup from your dev kit so that it is ready to be interfaced with the simulation. The next step we do is open a new terminal and enter your container again to start recording the data. And once we start recording the data, we hit the connect button on the simulator end to connect it with the simulator. And that's when your race actually starts. And that's also the reason why we have given you the first lap as a warm-up lap. so that any delays in this process doesn't affect your race time. Once this race starts, we don't interfere with anything. We wait for the vehicle to complete 10 or 12 laps. And upon completion of the 12th lap, as you will see, we stop the data recording and we kill everything. So another important thing that you should note here is, because we will be entering your container from a new terminal for recording the data, please don't use bash scripts or bash RC files for executing your container commands. Please use the entry point script, because if you're using bash RC file for doing that, then if we are entering into your container from a new terminal, it will again do all of those execution of all of those commands, which will basically be a problem for us while executing your submission. So it is highly advised that you use the entry point script rather than using the bash RC file. I'll now ask Chinmay to discuss the technical aspects and the other aspects of the orientation.
Thanks, Tanmay. So for those of you who might not have seen this video earlier, this is what the simulation framework would look like. This is basically a feature of the F110 or RoboRacer digital twins in Autodrive Simulator. So this is what you will be predominantly working with. This video, of course, covers some of the aspects that are not a part of this competition, but are possibilities for you to maybe consider for exploring or your own research. But for the competition, we would be utilizing a framework that would look very, very similar to this. And this video basically covers some of the high level features of the simulator itself. So you can get acquainted about that in this video, or you could also refer the technical guide, which covers all of this in an exhaustive fashion.
So even though this competition is basically a time attack racing with a single car on the track, as you can see in the future, we definitely have plans for having multi-agent head-to-head races. So for those of you who are here for the long haul, you might be interested in starting developing your solutions so that they also are ready for multi-agent racing in the future.
So to cover the high level aspects in the technical guide, we have details about the simulator, the dev kit, as well as tips and procedures of how you would go around with the submission processes. One thing that I would like to highlight here is that some of these things might not be beginner friendly. For example, you would need expertise in terms of programming languages, middleware frameworks such as ROS2, containerization approaches. Version control is optional but highly recommended again. So it is good to have either a person who has expertise in all of these, or at least a team that is conversant with all of these aspects collectively. So there could be people who are very conversant with programming, but may not know much about containerization, but then someone else in the team could take care of that and those kind of things. So that's just a heads up for you to consider in terms of task allocation and planning. Another thing that's worth highlighting is that we would be running all of your solutions on the same machine, and the specifications are mentioned here on the slide as well as in the technical guide for you to refer. Please consider these computational configuration or constraints while you are devising your algorithms. We have purposely allocated a decent compute hardware for evaluating your solutions. So we expect that this competition should go smoothly without any hiccups pertaining to that. Again, in the technical guide, we have exhaustive information regarding the system requirements for the simulator, as well as the user interface, which includes both the menu panel that you see on the left-hand side of the GUI and the heads-up display on the right-hand side. We have documented what all of these individual input fields as well as the buttons and what all of this data and live streaming information really means, what each of these aspect is, and how you can basically understand or interpret this information. Then we also have information regarding the vehicle itself, that is the RoboRacer race car that you see rendered here. We have defined all the different frames of references, that is transforms, as well as high level details on the vehicle dynamics as well as sensor physics. And with respect to the environment or the racetracks, again, we have defined the transforms and details regarding the size and structure of the racetracks, as well as what could be the potential design and features that you could expect to see in the final competition racetrack or future competitions. Similar to the simulator, we also have details on the dev kit. These again include the system requirements, firstly, and secondly, the package structure. So here we have the for those participating from earlier competitions, we have renamed the or rebranded the package from AutoDrive F110 to AutoDrive RoboRacer now, and all the package contents or configurations and structures have been highlighted in the technical guide. There are some new additions. For example, we have added new requirement files for you to set up your local environments if you are conversant with or comfortable with operating in that way. But again, we would highly recommend you to get started with the containerized versions of the dev kit at least as soon as possible, so that your submission process becomes much easier. Finally, we have details on the data streams as well, and this includes the different topics that we have exposed via the ROS2 API. What are the type of these topics? This could include things like, is it a sensor streaming topic? Is it an actuator command, or is it just a debugging message, and things like that. We have also added the message definitions for all of these if you want to refer to that in just a single place. Of course, you can use ROS2 command line interface for that conveniently. And finally, we have also included details regarding the access restrictions for all of the topics. Please make sure you read all of this carefully, especially the access restrictions, because what we expect from all the teams is that they make use of the sensor streams, they devise their own perception planning and control algorithms, and then the control actions are relayed back to the simulator. Although there are topics that give you privileged information to things like the transforms directly, wherein you can just override localization using the transforms or the indoor positioning system estimates. We have mentioned that those are access restricted topics, so you should not be using them in runtime during your vehicle when your vehicle is racing on the racetrack. You are allowed to use them for debugging purposes or for offline processes, but when your vehicle is running in autonomous mode and racing on the racetrack, the vehicle should not be accessing these topics.
So two things to clarify again. One is the package structure. We have already provided you with the autodrive underscore RoboRacer package, and it is expected that you don't modify this package, but create your own participant package. You can name this conveniently according to your name convention, but you access the topics directly from the nodes that expose the topics from the AutoDrive RoboRacer package without modifying that directly. That's the first thing. And the second thing is about restricted access. As I mentioned, you can access the restricted streams for debugging purposes while you are developing algorithms, or for any offline processes, like for example training your RL algorithms. You could use those as reward signals or to formulate reward signals, but not necessarily as the input or the observation space, so that when you are deploying your algorithms, you don't necessarily have to subscribe to those at runtime, because if you are subscribing to the restricted topics at runtime, we will have no option but to disqualify the team.
Finally, the technical guide highlights aspects regarding competition submission, and this includes several things as listed on the slide. First of all, we have details regarding setup of the containers. This includes both instructions for both the simulator as well as devkit. Then the steps for executing these containers. Then we have a few troubleshooting tips that are not just useful for this competition, but in general, when you are working with Docker containers, this could come in handy. Then we have a few guidelines for how you could go around developing your algorithms. And finally, we have guidelines as well as step-by-step instructions for you to uh, submit your containers as solutions for the qualification as well as the final competition race. On the right hand side in the graphic, what we have depicted is the high level overview for you to understand or get a glimpse of. So what you will be working in is this small space. What we have already provided is the simulator as well as the dev kit working implementations that will be communicating via the API in real time. And what you are expected to work in is your own package or packages in the same workspace without modifying the AutoDrive RoboRacer package that we have given. You can create multiple packages if you want in the same workspace, or you can have just one unified package. It's up to you and your design choice. But you would be basically devising the autonomous racing software stack here that would be communicating via the dev kit to the simulator, and all of this will be running in loop. That's the high level idea. And you would have already seen this in action in the video that we showed earlier. One important tip I would say here is that we anticipate that some of the teams may not have worked with Docker containers previously or might be at a beginner stage. So one good tip there could be that you could start developing your algorithms locally using the local devkit version, and then worry about the containerization later. But again, make sure that you worry about containerization early enough so that this does not come to the last minute rush, because this is a significant step and again a very important and required step for all the participants. So you could potentially divide this task among yourselves. So a subset of the team could look at developing the autonomous racing algorithms, and the subset of the team could potentially try to get familiar with Docker containers and the submission process itself. And then you could come together to containerize your final refined algorithms, test them, and then push them to the container registry. These are some of the interesting or helpful aspects of the simulation framework itself that we would like to highlight in the orientation. Again, information regarding this as well as some other details have also been provided in the technical documentation or the technical guide. So first here, what we have is a distributed computing mode. So you could optionally run the simulator as well as devkit on one single machine. But what happens is running all of this on a single machine could typically take up a lot of compute power. And especially if you have algorithms or processes running on the CPU and GPU, then data transfer across CPU and GPU results in a huge bottleneck. So we would also advise for you to maybe you benefit from the distributed computing mode. What you could do is run the simulator on one machine, run the dev kit on another, and just one thing that you have to make sure is that these two machines are now connected via a same or a common network. And what you could do is basically enter the IP address and port number, which is by default 4567, of the machine running the dev kit within the simulator GUI, and that will establish the communication and do the job for you. It will basically run the exact same way as it would on one single machine, but this way you have the capability of leveraging the power of distributed computing.
A fun thing to do here for teams who are thinking of participating both in sim racing as well as physical racing leagues is to deploy your algorithms or the dev kit on the physical F110th board, the Jetson, and interface that with the simulator that could be one of your lab workstations or laptops. And that way you would know that your algorithms are performing in real time on the edge device and still being able to communicate with the simulator. That's just a fun thing for someone to try out.
The other helpful tip here, I would say, is operating in GUI mode or headless mode. So by default, you could just run the executable of the simulator and that would just spin up an application window for you, where you will have the ability to interact and observe everything that's happening in the simulation. So that's the GUI mode, which comes by default. What you could also potentially use is the headless option. So again, within the headless, you have two options. One is you could just operate in no graphics mode, wherein entire rendering pipeline would be disabled. What that would do is boost the performance significantly. But the challenge here is that since the entire rendering pipeline is now disabled, you would not have access to the camera frame from the vehicle because that also operates on the same rendering pipeline. The other option in within the headless mode itself is to use a virtual frame buffer to turn off the simulator window rendering, but keep the internal rendering intact. What that will allow you to do is offload the computation that's required for rendering the simulation window, but the internal camera rendering would still be intact, which would enable you to still access the camera frames. So these are the three levels of graphical offloading, I would say, that could help you if you have relatively older compute. Other option again here is that even in the GUI mode, you have three internal options of toggling the graphics quality from low to high to ultra. So you could also use that. By default, the simulator is either operating in ultra mode or the low graphics mode. You can easily toggle that via the button in the GUI that's given in the menu panel. So with that, most of the important technical aspects have been covered. Again, there are a lot more that have been highlighted in the technical guide for you to look at, but these were the most important ones we believe from the earlier deployments of the competitions. So now let us go to the demonstrations. So first of all, we could maybe just give a quick walkthrough of the competition website itself. So most of you would have already visited the website enough number of times by now. But what we have or what we would like to highlight is, first of all, we have information about the competition in general, then information about the organizers. Then we have the timeline, competition timeline, followed by the registration information. And what is most important are all of these resources. As we highlighted earlier as well, please make sure that you are using the resources from this page itself, not from any of the earlier competitions or anywhere outside in general that you might find on GitHub or other places. Please make sure that you use the simulator as well as the dev kit that has been provided on this competition website specifically. It could allude to the Docker containers as well as the local resources. And here is where we will be releasing the submission forms for the first and second phase, which is the qualification and the final race. And this is where you will be basically accessing these forms to submit your solutions. And finally, the results would be announced for the qualification around May 5th and for the final race around May 12th. And this is where you would see all the leaderboard and rankings. You could refer to the earlier competition deployments for IROS or CDC here itself to get a sense of what all was populated in the website over time. And it would be the same process that we will be following for this deployment as well.
Another thing that you can leverage from earlier competition is the two different racetracks for the final races at IROS and CDC. So again, as I highlighted multiple times, the competition framework has evolved over time. So please don't expect everything to work as exactly as it does for the ICRA versions of the simulator or the dev kit. But to get a generic idea of how the tracks could look like, or if you are able to, or if you are interested, you could actually modify your algorithms to work with the older simulators as well and test them out so that you can basically have generalization experiments ahead of time.
Just one final note is, if you are working with older competition frameworks, make sure that you are using both the simulator and dev kit from that specific competition, because cross compatibility might not work since the competition framework has evolved. Especially, we have added optimizations that make things efficient, so the older versions might not be exactly compatible with the newer ones.
And same applies for the dev kit where the topics would be definitely different with the F110 namespace and things like that.
Next up here, we have a video that demonstrates how to use the competition framework itself. Again, this video has been made available online for you to refer n number of times at your convenience. But we just wanted to highlight here the fact that this video exists for those of whom might not be aware. So you can refer to this video in terms of setting up or using the competition framework itself. This demonstrates everything right from installation all the way up to using it for or getting started with the dev kit connected to the simulator. It's just a 5-minute video or less than 5 minutes. So not a long video for you to refer whenever you feel the need to.
So here, for example, we have demonstrated how you could use the example entry point script to directly run the base sensor visualization script for the dev kit, as well as launch an RViz instance and then visualize everything without doing or running a single command manually. And that's what you see in the demonstration video as well.
The next video that we have, again, this is publicly available, is regarding the reset functionality. So we do allow a soft reset functionality via API now. We just wanted to highlight that fact. You could reset the simulation via the API. So this is being currently demonstrated in the video using the teleop interface. The R key specifically here resets the simulation, but you could basically use a Boolean message type to reset the simulation via the API, and this could be particularly useful while training or retraining your RL algorithms. Finally, we would like to also highlight the fact that we have created this Foxglove interface for visualizing all of the race metrics and data for all the deployments. We typically use this for evaluating all the teams, but we have also open sourced this interface itself. So if any of the teams wants to use their own interfaces, they are of course welcome to do so. But if someone wants to benefit out of this, they are also again welcome to use this interface. This none of this aspect of visualization or debugging is mandatory or compulsory in any sense. It's just for you to have an intuitive sense of how your vehicle is performing and what could be tuned or what are the effects of tuning specific parameters of your algorithms and things like that. With that, I believe we have covered most of the important details regarding the competition. Here are a few general resources regarding the AutoDrive ecosystem itself, if anyone is interested. But at this point, we would like to open the floor for any questions or discussion. Again, thanks a lot, everyone, for joining in and your interest in the competition itself. If you have any questions, please feel free to unmute yourself and ask, or you could also post the question in the chat.
Hi, thank you so much for this presentation, both Chinmay and Tanmay Samak. Really appreciate you doing this here. I I thought I'll take this opportunity to ask a question that I had in my mind during the middle of your slides.
Yeah, sure.
Yep. So regarding the containerization, if you could go back like 5 or 6 slides back, that way I can point specifically. Yes, think a bit more up. No, I think in the tech. Yeah, here I also had a question here in this submission guideline. So you are mentioning about only one Docker Hub repository that is being allowed per account. Can you please mention that again? I couldn't follow clearly. What
Yeah, sure.
is? I know the GitHub thing is unlimited, like that is standard, but I would like the, some more clarity on how we can do the trial run with the containers and also do the practice run and also the final run. Like, yeah, I would appreciate if you can go over the timeline of how we use containers and different submissions for the test lab and even the main race event.
Sure. So regarding this is all regarding submission privacy. So you can potentially create publicly accessible repositories as well. But this is just in case you want to store everything privately until the competition ends at least. So for GitHub, GitHub allows all the accounts now to have multiple private repositories. So this should not be an issue at all. Regarding Docker Hub, the challenge is that Docker Hub allows only one free private repository for every account. So you cannot have multiple private repositories at zero cost. You can, of course, choose to pay if you want, but that may be a limiting factor for some of the teams. So what we have recommended over here is that you could either, if you have an existing Docker Hub account and you don't have any private repository as of now, you could create a new private repository in that account. Or if you already have a private repository, what you could do is, for the sake of the competition, you could create a new account that will grant you one free private repository newly. And then you can use that private repository to submit your, or basically push your containers for the qualification as well as the competition phases. Now, for the two different phases, what you could do is use the same repository, but different tags. So for example, if you look at the Docker containers that we have released ourselves in the resources, we have two different tags. One is explore and one is practice, and there will be a third tag compete in the future. So what we have done is there is one single repository, and of course for us it is publicly accessible, but you could have a single repository that's private for you, and then have multiple tags in that for the qualification round and the final race. You could choose to call them whatever you want, but make sure that you submit your containers accordingly in the Google form that we'll be sharing. Does that clarify your question?
Yes, that helps. Yeah, thank you. Yeah, the tags is some. Yeah, I understood the point now. And if you also go towards the end, yeah, in the technical aspect, I had another question
Tell me
there.
when to stop, which slide you want me to.
Thank you. Yeah, I will tell you. Yeah. Yes, I think in the GUI uses headless mode. So you
Okay.
mentioned in the headless mode, like to all this different ideas you've shared to optimize our performance basically, right? Because running everything in the same machine can be computationally extensive, and having the headless mode would not give us the camera view of the track in our car. And can you please mention about the GUI mode again? Like
Yeah, sure.
how
So just
exactly we reduce the uh, or performance, or like we reduce the capability and still have the camera view? I couldn't get that part clearly.
Yeah, sure. So first of all, if the default simulator, if you just double click on it or execute it via terminal, it will run in GUI mode, which is basically you will see an application window open up like this on your
Right.
computer, and it will be rendering by default. One quick way to reduce the burden or the computational cost is to resize the window manually to a smaller window size so that the effective number of pixels that are being rendered will be less, and that way you are offloading your workload from the GPU. The second thing that we have given an option of is to change the rendering quality right within the uh, graphical user
Oh,
interface.
okay. Makes sense. Yeah,
So if
I
you
have
see
seen that.
here,
Yeah.
you have it in ultra quality, but if you just click on this button, it will change to low or high as well. And depending on the compute that you have, you can choose or set your graphics quality. Again, for everyone here, we will be running the simulator in ultra quality by default, unless you specify us that it needs to be run in low quality or high quality. And we will only entertain your ask if you are using any computer vision based algorithms. Otherwise, by default, we will be running the simulator in ultra quality from our side.
and the reason for that is we have ensured consistent frame rate as well as
Data transfer rate.
for the
Okay.
simulator as well as dev kit in ultra quality mode.
You
Another
have the
thing,
sufficient hardware to support this. Yeah, I understand.
another important thing that I would like to probably reiterate in the headless mode again is that we have two options in the headless mode. One is where you will be using no graphics, and again, the details regarding this have been made available in the competition documentation. So one is just no graphics mode, wherein there will be no rendering whatsoever. So this will basically disable all the rendering, including the vehicle camera, as mentioned on the website. And this is the technical
Right.
documentation. The other option is to use a virtual frame buffer, wherein you will be using the xvfb run command to launch the simulator. And what this will do is it won't have a physical window pop up. So that rendering would be saved, but it will still compute all the ray tracing and everything that essentially happens in the simulation to render the first person camera that looks something like this for you, and that will be made available via the API. So you could utilize the ROS 2 topic for that to access the camera frames. So these are again two different options that you have within the headless mode, and then you also have the GUI mode itself.
And
Okay.
again,
Interesting.
apart from the camera, everything else will still be the available as same in the GUI mode within the headless mode as well. So for example, most of the algorithms that teams use are prominently LiDAR based. LiDAR as well as other sensor streams will be available, just camera will be affected, and that too only in the no graphics mode.
Makes sense. Thank you.
Most welcome. Are there any other questions?
If not, we can end today's orientation. Also, feel free to post any questions if you have on the Slack channel later as well, because most of the time you can't think of a question on the fly, but once you start working with these things, you may have questions. So feel free to post them on the Slack channel. Us as organizers, we will definitely try to help you, but definitely I'm sure that other team members who have either experienced those kind of problems or even are already surpassed and never encountered those issues will be more than happy to help you. So yeah, let's keep in touch via Slack as well. But again, I would like to thank everyone for joining in today and have a good day or good night, depending on the time zone you're in. Thanks again. Bye bye.